Hello, everyone, and welcome to Inclusive Design and Testing, making your app accessible. My name is Maya Ben-Ari. I'm a product manager on Android accessibility. With me today is Casey Burkhardt, who is an engineer on Google accessibility team. And we'll also have Michal, who runs applicable Google Tel Aviv program. Michal will be joining us by video. We are very excited to have you all in the session today, and thank you all for coming. Our agenda will start with a brief overview about accessibility. Then we'll tell you more about the applicable Google Tel Aviv program. We'll dive into inclusive design best practices, and we'll have a section about testing. So first, what is accessibility? Accessibility is about creating products that are usable by everyone. This includes also users with disabilities, such as vision impairment or motor impairments. But I'd like to rephrase this definition slightly differently. And I would say that accessibility is about challenging the assumptions we make about our users. For example, can the user see the device? Can he or she distinguish between color? Can the user touch the device? And can the user hear the sound that the device is producing and speak back to the device? Now, this is not a small number that we are talking about. 20% of the US population will have some sort of a disability during their lifetime. But this is not all. Challenging the assumption we make will benefit all users. As some of the technologies that were developed in the past, such as speech recognition and work prediction, started as technologies for users with accessibility needs. But this is not all. We are all users with accessibility needs sometime. This is called situational disability. For example, when we drive our car, we cannot look at our device. When we are in a noisy environment, we cannot listen to the sound that the device is producing, and we cannot speak back to the device. And when we carry heavy bags from the supermarket, we cannot use our hands to interact with the device. So we want to create an inclusive experience for all our users, regardless of what restriction they might have. Now, in the next section, we're going to tell you more about applicable Google Tel Aviv program. So what is applicable? Applicable is the program that helps startups to make their app more accessible. And applicable does so by inviting developers and startups to their campus to witness how blind and motor impaired users are using their apps. So this is a video that Michal Waltner from Google Tel Aviv just sent us. Let's move to the video.
My name is Ilana Benish, and I am 38 years old. I born blind. I had many surgeries, and they have succeeded to improve my sight in one eye. Independency means access. Many of the technologies that are available today are not accessible. And that's why I came to Applicable.
My name is Michal. I'm the program manager of Campus Tel Aviv, which is a Google space that is dedicated to entrepreneurs and startups, meaning helping the local ecosystem to create amazing startups. I started thinking, how is it possible that this huge market is not being addressed? Because if they knew that with some easy steps, they can actually make their app accessible to this huge market, I was sure that they're bound to do something about this. So this is how the idea of this program of Applicable started.
My name is Ariel Kedem. I'm a mobile product manager at Fiverr. Fiverr is a marketplace for creative professionals. We're helping people productize and make money from their talent. Fiverr is trying to change how people work and allowing people with disabilities to work with Fiverr is something big.
So we started with visually impaired and blind people. Each table had a startup, mentors from the design world, from the product world, and developers sat together with a person with visual impairment and a person who's blind to see how he's actually using his own app.
My name is Jonathan, Android developer and evangelist in Get. Get is a leading platform for on-demand services like Get Taxi or Get Pizza or even Get a Doctor. And remember at the beginning, there was a woman who said, you're from Get? I'm not talking with you. Like, you're make my life awful. When you make this difference for them, first of all, you feel proud. Because like, you really help someone. One of the really small changes that we did that has huge impact was that we have, when you open the app, you have marketing pop-up right straight on the screen, and it doesn't have any label. So for the blind people, it was like home. We're showing a regular map with the address and order taxi button. And it wasn't aware that they're actually the marketing pop-up and they can't click on anything or using the talkback. And by just verifying that if your the talkback is a turn off, not to showing this pop-up, is like huge difference, because now these people are able to order a taxi instead of constantly clicking on the marketing pop-up and not understanding why I can't order a taxi. Actually, the impact was that she went out of the building and she said, now I'm able to order the taxi.
We actually did some really small change. We have a page of categories within Fiverr. It was built like a category next to a category in a very long page. And when we did one of the sessions, they just tell me, just build them one in a row and not one next to each other. So we changed it, we put it in the app on page, and it just changed dramatically how people navigate the app. Thinking about a simple experience, it just made me a better product manager.
With a really small effort, just to change a little bit bytes of code, to add additional stuff, and you can make really huge difference for them, for their daily routine.
Tagging your components on a specific page, giving an image the right alt tag. It's really something that when you change how you think, it's very simple. Enable the accessible view on your phone. Try to use the phone as someone who, just for example, can't see. This will affect everything you do dramatically.
Button 96, unlabeled. Button 13, unlabeled. Button 74, unlabeled. Button 18, unlabeled. Button 35, unlabeled. Button.
How was it? Disaster. Really disaster.
So after about half a year that we dealt with visual impairment and blindness, we went to the second stage of the program and addressed people with motor disabilities. So again, we opened testing labs. We brought the mentors, we brought people with disabilities, we brought startups, and we realized that this is definitely something that is so needed.
Take your phone in one hand and start to running and try to send a message during the running. You will have a lot of mistakes and you need to erase and retype. And this is my life when I'm using apps. I'm hard. I'm 39 years old. I'm working in Get as a senior QA engineer. I have cerebral palsy, and the effect of that you can see in my speech is I have a difficult speech, and my right hand is not functional, and also both two legs are not functional, and I have only one hand, and even in that hand I have, in 3 fingers I have a spastic. It's very difficult to reach all the corners with one finger. My wildest dream is that I will have the ability to put each button in a place that I want. I know that the designers and UI UX wouldn't have that, but it will make the app more accessible for me and for the many other people. This is my dream.
To meet with them, to tell them our needs, it was very, very important meetings.
My message to all developers will be, hey guys, you are there. You're actually the one that can have the power to change for a lot of people their entirely life.
I think about this amazing applicable session, every screen, page, or button that I'm adding to the app.
Make the app more accessible, it's a must. So now the ball is in your hands.
Accessible apps are changing our lives every day and will continue to change everybody's life every day.
So I'd like to thank Michal from campus Google Tel Aviv Applicable Program for sending us this wonderful video. From the video, we saw that sometimes small changes may have big impact on people's lives. For example, as Jonathan from Get, Jonathan is here, by the way, just adding labeling to the app that was previously not accessible made a huge difference. And finally, and then like suddenly, a user who couldn't use the app could now order a cab. So in the next section, we're going to get into specific suggestion on how to create a more inclusive experience for all users. So first, what is inclusive design? Every product decision that we make in our app may include or exclude certain type of users. So what we want is to take into this consideration those people with a different need and to design our app which is reachable and accessible to the different users. That all sounds good, but how do we do that? So the first thing that you need to do is to be familiar and try the different accessibility services. This is what Applicable Program is doing, is you want to understand the experience of different users with different needs. So first, what is an accessibility service? An accessibility service is a long-running privilege service that can do one of two things. One, it changes the way the user interacts with the design, we interact with the device, or second, it changes the way that the content is represented to the users. Now, today we have 4 different accessibility services available on the platform. The first one is TalkBack. TalkBack is targeted for blind and a visual impaired user, and it's basically a screen reader that the user can interact with user using gesture, and the content is represented through text-to-speech. Now, let's take a look at that one. Let's switch to the demo. So now I'm inside of Android settings in accessibility, and I can go into TalkBack and turn TalkBack on.
TalkBack on.
I'll go to
Home button.
screen.
Home screen 1 of 1. Home screen 1 of 1.
So with TalkBack, the user has 2 ways to interact with the device. The first one is called linear navigation. So basically, for whatever icon or element that currently has focus, the user can use swipe gesture to move between elements.
Phone.
For example,
Messenger. Apps.
now, when the user wants to activate a specific element, he can basically double tap anywhere on the screen, and the element that currently has focus will open up.
Apps. Clock.
So this is linear navigation. The second way for a user to interact is called Explore by Touch. In this case, the user will put one finger down, and then he can navigate across the screen, and every element that gains focus, TalkBack will read out loud. Let's take a look.
Betterbug. Calculator. Chrome. Drive. Gmail. Clock.
Now, when the user would like to open that element, again, he can tap anywhere on the screen, and the element that has focus will open up.
Clock.
This is TalkBack. The second service that we have is called BrailleBack.
Showing items 1 to 2 of 2.
Thank you, TalkBack. The second service that we have on the platform today is called BrailleBack. Now, with BrailleBack, the user is interacting with a refreshable Braille display, such as this one. In this case, the user have this keyboard or the joystick, and he can interact similarly to how the user interacts with TalkBack. Just in this case, the content is going to be represented in Braille on those Braille cells with the DOS raising and lowering. So this is BrailleBack. The third service we have on the platform is called Switch Access. Switch Access is targeted for motor impaired users who have trouble interacting with a touch screen. In this case, the user can connect something which is called an adaptive switch, like this one. In this switch has two buttons. It can have more or less buttons. In this one, the user will set one of the buttons as next and one of the buttons as select. Then the interaction with Switch Access will be similar to the linear navigation of TalkBack. Just in this case, the user will interact using the buttons rather than gestures. Let's go to the slides, please. Now, the last service is called Voice Access. This is a service we recently launched. And the user can perform low-level interaction using his voice. If you would like to learn more about this one, we have the Access and Empathy Sandbox just outside of this room. Now, note, those are representative examples of the capabilities of accessibility APIs. Every developer can develop services similar to this one, but you can use those ones to actually test how your app interacts with accessibility services. Now, if you would like to focus on only two services, please test with Switch Access and TalkBack. Why is that? Because with Switch Access, what you can test is how accessibility services interact with your UI, which is basically testing your input. And with TalkBack, what you are going to test is how content is represented to the user. For example, whether you have labeling, so you will test the output. So with Switch Access and TalkBack, you are going to test both your input and output. Okay, so until now, we are familiar with the different accessibility services. Now, what you want to make sure is that your application works well with those. And how do you do that? You following Android accessibility best practices. In the next part of the presentation, we brought to you a couple of highlights that we gather from our testing data. So these are our top 4 common suggestions based on testing data of how to improve app accessibility. We have content labeling, touch target size, contrast, and view attributes. Now note, this is not a comprehensive list, but these are small changes that you can do in your app that may have a significant input, a significant impact. The first one is content labeling. Why do we need that? This is for visually impaired or blind users who rely on screen reader to understand what's going on. Specifically, screen readers need content description to understand UI elements without visible text. This is what we saw in the applicable video. Button 86, unlabeled. Button 99, unlabeled. So what you want is to use content description in your XML layout to describe the elements. For editable UI element, our recommendation is slightly different. In this case, use Android Hint or Android Label 4 for anything which is editable. Now, the next big question is, how do I write my content labeling? And our most important recommendation is make sure your labeling makes sense. So these are a couple of do or don't read regarding to labeling. For example, if you have an account switcher, how you should describe the content, switch to a Gmail, some kind of a demo account at gmail.com. What you don't want to do is to add a content labeling such as account switcher, switch to account mydemo@gmail.com. So please be succinct with your content labeling while describing enough context. The next one is if you have a close button, what you want to provide is a labeling such as close. You don't want to provide the labeling for a close button because in that case, the screen reader might read it as a close button button. So please don't include the type or the state of the UI element. Now, the last one, my last example, if you have a pencil on top of an image button, use content labeling such as edit and not pencil. So please describe the action and not the image. Now, our second recommendation is about increasing touch target size. This will allow users with mobility impairments to interact with actionable UI elements. So what we'd like you to do is to make your touch target size big enough. What is big enough? We recommend using touchable items larger than 48 by 48 dp. Now, it doesn't mean that the whole image needs to be 48 by 48, as you can see here with the magnification glass. In that one, the image is only 24 by 24. But we want that the touch area which responds to user input will be bigger than 48 by 48. Now, you can extend the touchable bounds beyond the view size using touch delegate. So for the next example, and to talk about contrast, I'd like to invite Casey onto the stage.
Thanks, Maya. My name is Casey Burkhart. I'm a software engineer on Google's accessibility engineering team. Our third best practice today is about contrast. Ultimately, this comes down to how visually distinguished your elements in your UI are. This comes down to the colors we choose to represent content in our UI. The way we measure contrast is by looking at the luminance, the brightness, of the colors used in the foreground and background of an individual UI element. Having a high level of contrast in our apps is important for users with visual impairments, but also for people with light sensitivity, like myself. And we want to ensure that we meet a minimum level of contrast between the colors we choose for the foreground and the background of our content. Now, there are a bunch of tools online that will allow you to plug in your color values and obtain what we call a contrast ratio. This is simply a ratio of the luminance of the foreground to background. There are a number of tools online that can be really helpful to go and identify these, and we'll actually see one in just a bit. So specifically, what do we recommend? For any use of images or iconography in your application, we recommend a contrast ratio of 4.5 to 1, meaning either the foreground or the background is going to be 4.5 times brighter than the other. For text content, our recommendation varies based on the size of text. If your text is large, that's 18 scale pixels or larger, we recommend a ratio of 3 to 1. For text any smaller than that, we recommend the 4.5 to 1 ratio. And on this slide, we can actually see a few examples of primary color combinations and how they stack up in terms of contrast ratios. So as we can see, white and yellow on black and white and yellow on blue both meet the 4.5 ratio. But note that white or yellow on red should only be used in combination with large text. We also see a few examples of color combinations that don't work well, such as blue on black, red on blue, or white on yellow. These shouldn't be used in combination with one another. Our fourth and final best practice for accessibility inclusive design is all around how your application represents its views within the view hierarchy. Android's accessibility services will use view attributes to determine how to represent and navigate content within your app. Here we have an example of a very simple demo application with 2 buttons. We're going to use switch access as an example to see how the application is interacted with the accessibility service. So in this case, the layout is very simple for button 1. It's simply a standard Android button within a linear layout. It is clickable by default. So let's see how switch access interacts with this widget when we try to click it. Let's roll the clip. So switch access focus is going to move to the first button. We'll hit select, and we see a little snack bar at the bottom indicating that the button's been clicked. This is the exact behavior we're looking for. It's simple and works as expected. Now we'll complicate the example a little bit for button 2. In this case, we'll add an additional linear layout, and we'll mark it as Android clickable equals true. Now, this represents that we have 2 clickable things in our hierarchy, the button and its parent linear layout. This can actually create some confusion and difficulty when using this application with switch access. Let's try it and roll the clip. So we're going to move focus to button 2. We're going to hit select. And we're actually presented with a menu where the user has to choose. Do they want to select the higher level clickable item or the lower level clickable item? And this is confusing because the user doesn't need to know the details about our application's view hierarchy. So we force the user to memorize that they need to click 1 or 2 within a particular application. This is rather confusing, but we can luckily fix this pretty easily. So the right fix here is, since this linear layout is not actually clickable, we'll remove the clickable attribute. Alternatively, since this layout really isn't used for anything else, we can just remove the layout entirely. View attributes can also affect how screen readers navigate content and present content to users within your application. Here we have an example of a receipt. We have information in this UI that is associated. We have a subtotal, tax, and a grand total that has a key value relationship with other views on the screen. Since these values are associated, what we'd really want is this information to be spoken as one logical unit by the screen reader. As you can see in this example, we just have a single relative layout with 2 standard text views. Nothing is defined as focusable. So each of these text views is going to be focused and spoken independently by a screen reader. And this has the potential to create a confusing experience because the screen reader user may not be able to associate this information linearly. So what do we do instead? Luckily, the fix here is pretty simple. Anytime we have a layout that groups associated information, we simply set Android focusable equals to true. And we will see now that the screen reader focuses that content and speaks it as one logical unit, which is the behavior we want here. So we've seen a number of examples of accessibility best practices, what to do and what not to do. But there's a lot more than just these four. You may find that throughout your development process, you run into unique accessibility challenges. So we encourage you all to go and review the material design best practices for accessibility. A link will be in the spaces for this talk. So now that we know about Android's accessibility services, how to use them, and we know about Android's accessibility best practices, let's talk about applying them and integrating this testing for these best practices into our development process. And with that, let's talk about testing. Our recommended approach to testing for accessibility is manual testing. As you've seen in the applicable video, engineers at startups are learning exactly how users with accessibility needs are using their apps through one-on-one interaction. This is a great example of how to do manual testing. It is the most reliable way to find the user experience pain points within our apps. So we recommend that you go and learn about each of Android's accessibility services and try them out in your app. Now, there are some challenges with this. It takes a lot of time to actually go through an app with each of these services, and scaling this across multiple applications can be a rather large endeavor. Understanding the user experience takes a lot of time, at least understanding what is expected of each of these accessibility services. Also, just eyeballing an application, looking at it, it's sometimes difficult to assess some aspects of accessibility. It's difficult to sometimes say, oh yes, the contrast is too low here, or this touch target is slightly below the guideline. So what we wanted to do was build a set of tools that could make these tasks easier for development teams. So we've created the Android Accessibility Testing Framework. And this is a Java Android library that is intended to look at Android UI constructs and make assessments for accessibility. We'll make recommendations for things you can improve in your application's UI to make things a little more accessible to people who need it. So this framework is integrated with a number of other testing tools that we're going to discuss now. The first is Espresso. It's a UI testing framework for Android. And we've integrated with Espresso and another framework, Robolectric, for unit testing, in a way that allows you to use your existing tests to leverage coverage for accessibility. So how does this work? We have one class. It's called Accessibility Checks. And it's used between Espresso and Robolectric to enable accessibility testing functionality in your current tests. So in Espresso, I simply call accessibilitychecks.enable within my test class's setup method. And in Robolectric, I simply annotate my test class with accessibility checks. Now, when I go and run my tests, we'll get some output. And here's an example of that. This is a Robolectric test that I've written for a test application. And this test itself asserts nothing about accessibility. It simply asserts that clicking a button performs some action. Because I've annotated this test class with accessibility checks, we get accessibility evaluation behavior for free anytime Robolectric interacts with one of our views. So as our test clicks on this view, we actually run our accessibility tests, and we found that this view is missing a spoken description for a screen reader. So this would be a good cue for you to go look at your content labeling, make sure you've provided content descriptions or appropriate labels. In this case, we actually prevented an accessibility bug from getting checked into our app's code base by relying on accessibility tests in our other test frameworks. Now, that's great for engineers, but what about other members of product development teams, app development teams? Well, we wanted to build a tool that leveraged the power of Android's accessibility test framework for other project contributors, too. So Google's recently shipped Accessibility Scanner at the end of March. It's a tool for all members of product development teams, technical or non-technical alike. It allows for quick, on-device, real-time evaluations of accessibility and will present suggestions for improving accessibility within your app very quickly and easily. Let's actually take a look at how Accessibility Scanner works in practice. Let's switch to the demo. OK, so here I have a device with Accessibility Scanner installed and enabled. There's a floating action button that appears on top of every UI. And I'll open up a test application that we created, which intentionally introduced some accessibility issues. To run an evaluation, I'll simply tap on the scanner button. And in just a few seconds, we'll see an overlay showing us which areas of our UI may need some work. Let's take a look at a few suggestions here. So it looks like this item is missing a description for a screen reader. We should go back and look at the content description we may have missed here. It looks like we have a small touch target here. We can even get the specifics about the current size. And it looks like we may have some low contrast text. It looks like we only have a contrast ratio of 1.9 here. So we'll want to fix that. Accessibility Scanner makes it easy to look at all the issues within your application's UI and even take those issues and share them with my development team. Now we can go and get these bugs fixed. We get a simple report with a screenshot, and we can send that off. Now that we can go and fix our issues, let's see how Accessibility Scanner performs on a UI where we've taken its suggestions into account. Looks like we're in good shape. That's Accessibility Scanner. Thanks. A few final words on automated testing. Think of these automated testing tools as a way to get first-pass evaluations of your apps for accessibility. We will not be able to find every accessibility issue that an app may have, and we won't be able to fully understand what a user experience is for various users with accessibility needs. So we do really advocate manual testing with Android's accessibility services to get that full picture. Finally, our testing tools are only as good as your use of them or the coverage of your other tests. In Roboelectric and Espresso, you're only going to be able to evaluate controls that you interact with. So you want to make sure that your test coverage is good if you expect good coverage from the accessibility automated tools. Similarly, Accessibility Scanner can only evaluate the things that it sees on the screen in that present time. You may need to do separate evaluations for portrait versus landscape currently. So just a few caveats. These tools are here to help you identify things quickly and prevent bugs from being checked in, but always use manual testing approaches to validate your user experience. And with that, I'd like to hand it back to Maya to wrap up.
Thank you, Casey, for the lovely demo. So you saw today inclusive design can create a better experience for everyone. And we recommend following these three first. First, get familiar with the experience for users with accessibility needs by trying out accessibility services. Specifically, please try out TalkBack and Switch Access. Second, follow accessibility best practices. In the next slide, we're going to present a couple of links. We'll also share those links on these talk spaces. And finally, develop and test with accessibility in mind. And we provided today some tools such as Android testing framework with Roboelectric and Espresso and accessibility scanner to try those out. Now, final word, the sooner you consider accessibility users, their needs, the better you can address those needs and design a better experience in your app to include all types of users. So these are a few links. This is what's next. Waiting for people to take pictures. OK? All good? One more? One more. And I'd like to thank Casey and thank Michal for creating this session.
Thank you very much.
Thank you, everyone.